Network theorems. Network theorems is one of the very important topic from the electrical circuits or circuit theory subject. So this topic is used to determine the parameters like voltage, current, impedance of the given network. So these theorems are used to simplify the network's easy representation purpose. See, mesh analysis and node analysis, another is circuit reduction techniques. All these techniques are used to find the unknown parameters like voltage, current and impedance parameters here. And this topic is also used to find the same analysis, same parameters, but using network theorems, the simplification becomes easy. If the network has more number of meshes, more number of sources and more number of nodes, then to solve or to determine the unknown parameters, network theorems are used. In this theorems, approximately we have to discuss 8 theorems. Every theorem has one specific image, one important characteristics are there. So we have to discuss what is the importance of each theorem and where it is used. Each theorem is used in different application purpose. So we have to discuss applications of the network theorems also. So in this topic, in this network theorems, approximately we have to discuss 8 theorems. Those theorems are superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, Millman's theorem, Telegen's theorem and reciprocity theorem, duality theorem, and one more also there, substitution theorem. So now we have to discuss all this. First we will go through the superposition theorem. So I will explain in this what is the theorem, the statement of the each theorem and where it is used. So the applications of the each theorem and what are the conditions for theorem, like what are the advantages and disadvantages. These theorems are not suitable for particular networks, those are comes under limitations. So what are the limitations of each theorem? We will discuss each and everything clearly in this topic. So now first we will go through the superposition theorem. This is one of the very important theorem to find the linearity. To find the linearity of the system, superposition theorem is used. So superposition theorem is used to find whether the given network is linear network or linear system and linear element analysis purpose. This theorem is used. And this theorem is applicable if the network has more than the one source. If the network has more than the one source, then the finding parameters are very difficult. Then superposition theorem is used to solve or to find unknown parameters. Like superposition theorem is used to find voltage or current of a branch if the network consists more than the one source. So now the statement is here, in any linear bilateral network. So one of the very important point here, superposition theorem is applicable for linear and bilateral network. In any linear bilateral network having more number of sources. So this is also important here, having more number of sources. If the network consists of one source, this is not applicable, there is no use of the superposition theorem. So if the network consists more number of sources, that means more than the one source. So more number of sources, the response in any one element, is equal to algebraic summation of the individual element here. So algebraic summation of individual element. The response in any one of the element is equal to algebraic summation of individual elements. This is the standard statement of superposition theorem. So this theorem statement is, in any linear bilateral network having more number of sources, the response in any one of the elements is equal to algebraic summation of individual elements. So the response in any one of the element is equal to algebraic summation of the individual elements, means individual responses. So if the network connected with more than the one source, here at a time we have to apply one source and remaining sources has to eliminated. So due to that source, that response is called individual response. So here I wrote clearly, individual response is the response of the circuit due to one source. This point is important. The response of the circuit is due to one source is called individual responses. But the network consists how many number of sources? More number of sources. But here we have to take only one source. Remaining sources has to eliminated here. Remaining sources are eliminated. So remaining sources are eliminated means that elimination is we have to apply internal resistance. So the eliminated sources internal resistance have to apply here. So internal resistance of each source has to apply. The complete elimination means not removing the circuit. The internal resistance of the circuit has to apply. So internal resistance of the voltage source ideal case is 0 and practical cases it has some resistance. So if it is an ideal condition we have to apply internal resistance of voltage source is 0. So internal resistance of voltage source is 0 means it acts as a short circuit. So now onwards we have to remember, if the voltage source is ideal voltage source, immediately we have to replace with a short circuit because internal resistance of the ideal voltage source is 0. And similarly, current source internal resistance is infinity in ideal condition. In ideal condition, internal resistance is infinity. In practical case, the resistance has very high resistance is there. So internal resistance of current source is infinity. So current source acts as a open circuit. So individual response is nothing but the response of the circuit due to one source. Remaining sources are eliminated. That elimination is voltage source acts as a short circuit, current source acts as a open circuit. Voltage source acts as a short circuit, current source acts as a open circuit because internal resistance of the voltage source is 0, so it is short circuited, and the internal resistance of the current source is infinity, the current source is open circuited. So these are the conditions for superposition theorem. So superposition theorem is used to find the response of the circuit. If the network consists more number of sources. So from the superposition theorem, simple statement is total response is equal to sum of individual response. Total response is equal to sum of individual responses. So individual response is nothing but the response of the circuit due to only one source, and remaining sources has to eliminated. So that sources elimination is voltage source acts as a short circuit and current source acts as a open circuit. So voltage source is short circuited and current source is open circuited. And another important is that dependent sources remain same. So don't remove the dependent sources. Here all this elimination of the sources are only independent sources. Dependent sources are not eliminated, dependent sources remains the same. So remain same means those sources are not eliminated, those are connected as it is. So dependent sources are not eliminated, only independent sources are eliminated. This is another important point. Now I wrote some important points here from the superposition theorem. These important points are comes under advantages and drawbacks also. So I wrote combined here. So this theorem is applicable to linear network. So superposition theorem is applicable for linear network because the statement starts with here in any linear bilateral network. So any linear bilateral network. So the network should be linear network and bilateral network. So this theorem is applicable to all linear networks. It is not applicable for non-linear elements, means non-linear networks. So this point is important. So this is not applicable for non-linear networks. This is comes under drawback. Not applicable for which type of elements? Non-linear elements like diode, transistor. Those type of elements for superposition theorem is not applicable. This is completely applicable for linear elements. To find the linear system purpose, there we have to check with superposition theorem only. Total response is equal to sum of individual responses. And another point is, this theorem is used to determine voltage and current parameters. This theorem is used to determine voltage and current parameters. So these points are important here. Superposition theorem is used to determine voltage and current through any one branch or voltage across any one branch. But this is not suitable. This is not suitable to determine power measurements. So this is comes under drawback. Not used to determine the power finding analysis purpose. Superposition theorem is not used. So this is comes under drawback, and this point is comes under advantages. Then one more point is this superposition theorem is applicable if the network has more than the one source. If the network has more than the one source, then this theorem is applicable, otherwise it is not applicable. So the network consists more than the one source. So here I wrote some important points from this superposition theorem. From this, if you want to write advantages of the superposition theorem is, it is applicable for linear networks and it is used to determine voltage across any one branch or current through the any one branch, and it is applicable for if the source network consists more than the one source. These are the advantages. And if you want to write drawbacks or limitations of the superposition theorem separate purpose, write these points here. It is not applicable to determine power measurements, and it is not applicable to determine power, and it is not applicable for non-linear networks, and it is not applicable for single source network. So these are the important points from the superposition theorem. First note down all this, and later I will explain how to find out current through one branch and voltage across one branch, means individual responses and total responses from this superposition theorem. So please note down these points. See, now we will go through some problems from the superposition theorem. So superposition theorem, how to apply the superposition theorem and what are the steps are required. So which method we have to follow. So all this analysis purpose, here I will explain few examples. So first we will go through the one simple example. Here I wrote one simple example. This example we have to solve with superposition theorem and nodal analysis method also. So according to the given network, so this network consists totally two sources are there. One is 24 voltage source and another is 9 voltage source, and remaining elements are resistive elements are there. Then the question is given here, find the current through this branch. So initially here I am applying a nodal analysis. So according to the nodal analysis, first find out the number of principal nodes. Number of principal nodes are 2 nodes are there. So this is first node. So and here second node. Second node, this is acts as a reference node. This voltage is 0 volts. Then apply nodal equation. So one nodal equation is enough, because from the nodal analysis there we discussed number of nodal equations are n minus 1. So one equation is enough. Then apply nodal analysis here. So V1 minus 24 by 2, V1 minus 24 by 2 plus V1 by 6 plus V1 minus 9 volts by 3 is equal to 0. So this is nodal equation here, nodal equation at node 1. Then simplify this. To simplify this purpose, here I am taking 6 is LCM. If you take 6 is LCM, then it becomes 3V1 minus 72 plus V1 plus 2V1 minus 18 is equal to 0. Take LCM 6 here, then simplify this. Here multiply with 3 and here multiply with 2 and this write as it is here. Then later, after simplification, the V1 it gives the 15 volts. So V1 is 15 volts. Then according to the given question, from the given question, the question is here, find current through the I, current through the 6 ohms resistor. That means find I value. So current through this resistance is voltage by resistance. I is equal to V1 by 6, 15 by 6. 15 by 6 is approximately equal to 2.5 amperes. So here current through one branch using nodal analysis method I applied here. Now for the same problem, here I will explain how to apply superposition theorem, right. So from the superposition theorem explains total response is equal to sum of individual responses. So here we have to find out individual responses. Individual response is nothing but the response of the circuit due to only one source, So at a time we have to apply here one source, remaining sources are eliminated. That elimination is voltage sources acts as a short circuit and current sources acts as a open circuit. So here I am taking one analysis. First I am applying 24 voltage source. 24 voltage source is connected here, and here one resistor, 6 ohms and 3 ohms, and here one voltage source is there. So from the superposition theorem, only one source is applicable. So one source is applied, remaining sources are eliminated. So this source is here voltage source. Voltage source acts as a short circuit because internal resistance of ideal voltage source is 0. So voltage source acts as a short circuit. Now this is 3 ohms and 6 ohms, and here 2 ohms is there. Then I want to find out current through the 6 ohms resistor, because according to the given problem, find current through the 6 ohms resistor. This is individual response. That's why here I am writing this is I dash. I dash is nothing but the response of the circuit is due to one source, that is individual response. So I dash I want to find out here. To find this I dash, only one source is there, then find the total resistance. So here we want total resistance. To find the total resistance in between these 2 points, these two are acts as a parallel combination. So parallel combination formula is 6 into 3 by 6 plus 3. So already explained, 6 and 3, these two resistors are connected in parallel combination. Then the total resistance is how much? 2 ohms resistance. So 2 ohms resistance. And this complete resistance is in series with this one. So total resistance is 2 plus 2, it becomes 4 ohms resistor. So the total resistance of the network is a 4 ohms resistor and total voltage is 24 volts. Then I am finding total current I. Total current I is equal to total voltage by total resistance, 24 by 4, then which becomes here 6 amps. So the current through this branch is 6 amps here. The current through the source is 6 amps. This 6 amps is divided into 2 paths. Then we want current through one branch here. So I dash. Now from this, I dash is equal to total current into opposite resistance 3 by, so sum of 2 resistors. Then total current is here 6 amperes is there. So 6 into 3 by 9. Opposite resistance by sum of 2 resistance. 6 plus 3 is 9. Then which gives the 2 amps. So finally we got one response, individual response. The individual response is here 2 amps. The current through the 6 ohms resistor is 2 amperes. So 2 amperes is, this is individual response due to one source. But the network has 2 sources are there. Again we have to apply one more source. So number of times repetition is depends on the number of independent sources. Number of independent sources. Here independent sources are 2 independent sources. Due to one independent source, the response is 2 amperes. And similarly we have to find out the response of the circuit due to another independent source. So now draw the network. So 2 ohms resistor, 6 ohms, and here it gives the 3 ohms. Now voltage source is connected here. Voltage source is connected. So remaining sources are eliminated, means this source is eliminated. Now this is acts as a voltage source. Voltage source is eliminated, it acts as a short circuit. So voltage source acts as a short circuit now. Voltage acts as a short circuit. Then the current through this branch is required. So this is individual response due to second source. That's why I am writing here, this is I double dash. I double dash. The response due to second source. The second source value is here 9 volts is there. 9 volts. Now to find the total current, through the source purpose, first we have to simplify these two, because here we have to find out the resistance between these 2 points. In this case, here the source is connected, that's why we connected here resistance between these 2 points here. Now here the total 9 volt source is connected here, then we have to find out the resistance between these 2 points. To find the resistance between these 2 points, these two are acts as a parallel combination. So 6 and 2, these two are parallel. 6 into 2 by 6 plus 2 plus this complete network is in series with this one, this becomes 3. This is total resistance. Then simplify this here. 6 into 2, 12. 12 by here 8. 12 by 8 becomes here 3 by 2. 3 by 2 plus 3. This is total resistance RT. Then simplify this here. 6 plus 3, 9 by 2, approximately 4.5 ohms. Otherwise write as it is 9 by 2. Total resistance of the source is 4.5 ohms. Now I want to find out total current I, total voltage by resistance 9 by 2. 9 and cancels. Now it becomes 2 amps here. The current through this branch is 2 amps. So finally current through the source, 9 volt source is 2 amps here. This 2 amps current is divided into 2 paths. One path is 6 ohms resistor, another path is 2 ohms resistor. Now we required current through the 6 ohms resistor. So from that directly I am writing I double dash is equal to, according to the current division theorem, total current into opposite resistance by sum of 2 resistance. So 2 into opposite resistance is 2 by 2 plus 6, so this becomes 8. So 4 by 8, 4 by 8 is 1 by 2, that is 0.5 amps. So due to second source, the response of the circuit is 0.5 amps. This is also called as a individual response. So superposition theorem explains the total response is equal to sum of individual response I dash plus I double dash. So one individual response is 2 amps and another is 0.5, then finally which gives the 2.5 amps. So according to the given network, the current through the 6 ohms resistor is here 2.5 amperes using nodal analysis method. So this method is using nodal analysis, and this is using superposition theorem. So here for easy understanding purpose I explained using superposition theorem what are the steps are required and using nodal analysis. Finally the answer should be same, the current through the branch using any one method. We can apply any one method, Thevenin's theorem, Norton's theorem, superposition theorem, mesh analysis, nodal analysis, apply any one method. All these methods are used to find unknown parameter or to determine the unknown parameters. Those parameters are voltage and current. So now here I applied here one superposition theorem. Here I explained how to apply the superposition theorem according to the step-by-step analysis. So find like this, find out the individual responses, then write total response is equal to sum of individual responses. And for this network, the given network, if the question is find the current through this branch, so for this network nodal analysis method is the best method. Here just I want step-by-step analysis purpose I applied superposition and nodal analysis. So superposition theorem is not compulsory for this network to find I. According to the competitive exams point of view, our expected questions are find the current through this branch here. This type of questions are expected. Then immediately we have to apply nodal analysis for this problem. But particular problems, few problems, nodal analysis and mesh analysis becomes very difficult to find the unknown parameters. For few problems, nodal analysis and mesh analysis becomes very difficult. Then that type of questions purpose, immediately we have to apply superposition theorem. For easy understanding purpose, I explain one simple example here, superposition theorem procedure. Then I will explain few problems particular for superposition theorem only. So please note it down.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SciMethod.in app. If you open the app guys, you are going to see there. Let's talk about the store now. In some other branch, let's open a EEE branch guys. In the EEE branch you can see the content. In the content engineering, in the engineering we have electrical circuit 75 videos there. In that mesh and nodal analysis if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3 questions with solution, previous ESET questions with solutions, and at last we have what mesh and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys. Based upon the topic marks, it is going to be there in the not only in ESET but also in the government jobs and PSUs. And at last you have there an online test examination also in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ESET examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys for EC, EEE and Civil, this SSC JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board Junior Engineer and as well as ISRO guys. If you people are interested to watch all the full length videos in the SciMethod.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486925998. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.